What's up, guys? It's Mr. Hanson from at Mr. Hanson 414, and today coming at you with a geometry lesson. We're going to do 2.1 translations. Now, I'm not translating what you're going to say. We're going to be translating objects using rigid motion. So make sure you guys got your books, and let's get started. You'll notice before I get started, the spooky season. This is so weird. I'm trying to do things backwards. And before we get started, there's a proposal to call people that are subscribed to my channel as Hansonators. Now, I think I like it. I don't know if I love it. Let me know what you think in the comments down below. So I'm gonna hang up here today. We're in fall. We're rolling. We start talking about that. Rigid motion and the difference of rigid versus non. And I'm excited because translations, I think, are relatively simple. They make sense. So the big idea, the essential question is, how do you draw the image of a figure under a translation? Well, we got to kind of figure out what translation means, but essentially it's just being able to show what happened. Now, I'm not going to teach you guys the tracing paper way, but if you want to look through that, go for it. But we're not going to do that today. Something to reflect on if you did do it is, always thinking about parallel, perpendicular, neither. That can really help you guys understand how shapes are moving. But here we go. So using vectors, you may know what a vector is, you may not. You may have learned what a vector was from Despicable Me. So I can go this way. But a vector is a quantity. It has direction and magnitude, and that's important. It has to have a direction, so which way it's going, and a size, a length. It has to have both. The initial point is the starting point, and the terminal point is the ending point. So you're starting somewhere, you're going a certain distance in a certain direction, and you're going to end somewhere. So you can see the example here, and there's a vector, and it's named EF. Notice the little vector mark, or V. You can call vectors what you want. So let's talk about what a translation is. It's basically just moving something, sliding something, taking it from one position to another. So a translation is a transformation along a vector. So you're saying, here's the line, here's the direction, the magnitude that you're going to move this whole shape, this whole object, this point, these points. Such that the segment joining a point and its image has the same length as the vector and is parallel to the vector. So make sure that you get that definition down. That's something that you're going to want to use. So here we go. We got BB, baby. It's a line segment that is the same length as, it is parallel to vector V. So there's our vector that we're moving along. There is vector BB, or BB line segment that you are moving along. And notice the prime notation. You got some facts. Make sure you get your facts straight. Parallel lines are always the same distance apart and never intersect. So probably like your soulmate. Sorry. And parallel lines have the same slope. We know about slope, I hope. So here we go. You have a copy that you're going to draw of the vector with this initial point at vertex A. So it must be the same length. So how can you do that? You can use a ruler. You can use a tracing paper. I'm going to see if I can use a line, because otherwise I don't think I'll be able to be precise enough. So you're going to take the line that represents the vector, and I'm going to put it on vertex A. And again, I'm probably not going to be super precise because I'm working on this computer. But that's what we want to do. The copy must be the same length and it must be parallel. So you can check that. It looks good to me. Repeat this process for vertices B and C. So base, oh, that's not what I want to do. So it looks like I can't copy my line. So I'm going to do that again. So you're going to take this vector and you're going to copy it. Oh, that one's off a little bit. Let's say no to that one. Sayonara. You're going to do this 3 times. Now what you're doing, why didn't that delete though? Bruh. Let's just throw you over there. So you're going to move it along these lines, but you're going to move it in each direction from each vertex. So every time you have a point, I'm sorry guys, I am fooling around here. I don't know what's happening. Getting all types of stuff. So let's say this one's right. It's probably off a little bit, but I don't want to be the reason why you can't be great today. So there we go. Let's draw one more. So I'm going from point A, point B, point C, because I have those points. I know those points. Those can be my reference points. And they're all going to copy the vector that we were given, the length and the magnitude. So do your best. Now what you're going to do is you're going to draw the segments to connect the terminal points. So if you look here, they show you how it looks. Now obviously I'm doing it my way, but you're basically showing the dotted lines as we're going to move. So you're going to move it over there, and then you're going to copy it. You're going to draw the same shape. So, you know, this is your pre-image, and this is your image. Your image just got moved. And look, we made a nice little 3D art. I always thought that was so cool when I was younger. So move everything, every point, every line segment with the vector. So here is B. I'm going to give you a second. So now's a good time to pause. Do this one on your own, and then I'll show you how to do it. All right, so hopefully you've taken some time to try to figure this out. Remember that we're working with vectors, and vectors have direction and magnitude. So we're going to draw a vector from vector A that has the same length and is parallel to. The terminal point A prime will be blank units up and 3 units left, right? We're going from here to there. So to do that, we're going to go up 1, 2, 3, 4, 5. So 5 units up and 3 units left. So we're taking the entire shape. We're going to take all the points, all the vectors, not vectors, all the vertices, and move them along that slope. So to do that, you're going to draw 3 more vectors that are parallel from B, C, and D. So I'm going to try to freehand this because I think I can do this well. So from A, I'm going to go up 5. 1, 2, 3, 4, 5, and a la izquierda 3. 1, 2, 3. So that's going to take me from A to A prime, from the pre-image to the image. Make sure we're using that verbiage. And then draw that dotted line. It's like we're diagramming basketball plays out here. Same thing for B. So from B to B prime, we're going to go up 5. 1, 2, 3, 4, 5. To the left. See, check your left if you're a loser or not. 1, 2, 3. Oh, I think I counted that wrong. 1, 2, 3, 4, 5. 1, 2, 3. There we go. It's going to take me to B prime. And again, with these lines, I would use a ruler or a straight edge. Your phone works fine. We got D, so 1, 2, 3, 4, 5. 1, 2, 3. D prime. Notice that we're going the same length, same direction. C to C prime. 1, 2, 3, 4, 5. 1, 2, 3. C prime. So now that you have all those, you draw the line segments. You connect them to form the quadrilateral I feel like I'm a pretty good speller, but man, sometimes I don't know what be happening there. So we're translating with the vectors, so we just want to connect them. So doom doom, doom doom. It's kind of hard to see C down there. Doom doom. And again, I would use a ruler here. But because this is considered a rigid motion, we should have the same exact shape, the same exact size, the same exact line segment length, all that. There's a question there to reflect on. So, all these, try and do your own before you just let me do it for you. But how is drawing an image of an quadrilateral ABCD, like drawing an image of the triangle ABC, how they're different? So many answers, but the steps, to drawing are the same. It's different because there's an extra vector. And then you just got to remember to connect the vertices in the same order. So if you go from like, A to C or something crazy, you're going to draw something ridiculous. That's not what we want. So there's one for you to try. I would identify the vector. What's the magnitude? What's the direction? And it's going, down and to the left. And it's going over 1, 2, 3, 4, 5, and down 2 units. So that's how you do that one. I think you guys should be able to be translating things. Some geometrical Rosetta Stone. So now drawing translations on a coordinate plane. A vector can also be named using component form, and this is something that I never really had stick in my brain. So I would think that this is something nice for you guys to pick up on. And it represents the horizontal change and the vertical change. Now, I hope that that's ringing off some bells. Horizontal change, vertical change from the initial point to the terminal point. So then the component form would be PQ is 5, 3. What does that relate to? Horizontal change, vertical change. Maybe something like this. Maybe something like this. Delta Y, delta X. Slope. Talking about slope. So you can use component form to draw coordinates for the new image on a coordinate plane. It's basically just giving you precise directions, right? To move via units, and you don't have to worry about drawing the lines correctly. So this can give you more precise. And there are some rules, and these things are importante. Rules for translations on a coordinate plane. Make sure you pay attention to the signs and to what's happening here when you do the math, because if you get different signs and you don't do the math right, you could move in the same direction when really you shouldn't, or you could mess up the magnitude. So just be careful when you're doing the math here. So when you move an image to the right, A, and up, B, you use the rule X plus A, X plus Y. So you can see that these are for each individual, but you can combine them. So you can go up and left, up and right, down and left, down and right. Okay, so get that in your notes. Very important. So letter A. Here's an example for you. You have the pre-image coordinates, so let's make sure we're using that vocab. This is like that whole input-output. So we know all of the coordinates, right? We got 3 points that we're working with the triangle, and we have the vector. So this vector tells us what? That we're going to move right 4 and up 6. And you could count that. You could verify that. Predict which quadrant. Well, it's here in between. I got to always double count these, 2 and 3. If it's going up and to the right, I mean, there's not really much confusion there with those numbers. It's got to be in quadrant 1. And then we're going to write the new coordinates. So you can use the vector components to avoid having to, draw this out, sketch this out. You can just do the math. So we look for the rules. So the first rule is going to be X plus A, and then the second rule is going to be Y plus B, because we're going up and to the right and up. So you just add. So you add 4 to the original X and 6 to the original Y, and you get these 3 points. I think it makes sense to me. How are you feeling? This is a good time to do some inventory of your brain. Maybe go get some water. Maybe look up a Despicable Me gift. I love that movie. The minions are hilarious because if you're not careful, you'll end up being a minion without having that much fun. So make sure you're paying attention to the direction, right? Because it can be positive or negative. And if you don't know what you're doing, you could throw things off. So here's one for you to do. Letter B. You're given the 3 points, right? The pre-image coordinates, and you're given the vector. Notice how these are written like that as a vector. So what I would do is plot my points, plot my pre-image points. So 3, 0. That's A. 2, negative 2. That is B. And C is 4, negative 2. And that is C. Use a ruler or a straight edge. I don't have that. And y'all seen what happened with those lines last time. So let's move, though. Let's do what the vector says. So the vector says to go -2, 3. So we're going to go x minus 2, y plus 3. We're just using our rules. So you can set a table up. You'll notice that there's a lot of tables in this book. They want you to use the rules now. Some math teachers will just be like, well, just teach them the rule. You guys got to be able to visualize it, because I might not want you to do the math. I just want us to know how it's going to be. So you could be like, well, if I can see that everything's going to move 2 and up 3, that this will still be in quadrant 1. That's my prediction. I don't know how that line got there, but anyways, so x minus 2, 3 minus 2 is 1, 0 plus 3 is 3, so that's my A prime, right? So 1 and 3. Letter B, 2 minus 2 is 0, -2 plus 3 is 1, so 0, 1. There's my B prime, pre-image to the image. And then C, we got 2 and 1. 2 and 1. Wait, that don't seem right. One of these are off. Oh, duh. I graphed this point wrong, guys. My bad. My bad. Let me plot C prime real quick because I messed up my B prime. We all make mistakes. Everybody has those days. In 0. Wait, what? Let me double check my math. Sometimes I be rushing. So 0, 1. I plotted 1, 0. Duh. There's my B prime. Draw my line segments. There's my new shape. I translated it. I moved it. I'm feeling good. How are you feeling? So your turn. You're given the vector. You're going -4, 1. So left 4, up 1. So I would make a little chart. Do the math. Set up the rule. Plot your points. Draw them. Specifying translation measures. In this one, I'm not going to break this video up, so I want to see my average watch time increase because y'all been seriously skimping, and that, I mean, y'all seen them quiz scores. Specifying translation vectors. So you may be asked to specify the translation. So they can basically say, okay, here's 2 shapes. How do they move? So you have to determine the components, right? What's the horizontal change? What's the vertical change? And to go from A to A prime or B to B prime, well, let's see. So to go from B prime, we went B to B prime 1, 2, 3. I gotta make sure I can count 4 and 5. So 5 units to the right. That's there. And 1, 2, 3, 4 units down. So write the vector in component form. Try to make sure you guys remember what component form is. So B, here you go. Here's your chance to do it on your own. So take that chance real quick. Shoot your shot. You should end up coming up with that the vectors 5, 3. What is the component form of vector that translates a figure horizontally? So just horizontally. Think about that. It would be written A, 0, right? There's no vertical change. So if you're going vertical and not horizontal, it would just be 0, B. So keep those in your mind. I'm going to let you guys work on that one. How are the translations for 9 similar and different? Well, they move the points the same exact distance. So the size, the magnitude's the same, but it's opposite directions. You know, look at these negative signs where they go. So I can be like, I walked 2 blocks. Which way did I go? That's important. A translation along the vector maps P to Q. The coordinates of Q are 4, 1. What's the coordinates of point in P? So you're missing some information. So it's, you know, I would draw a picture for this. You know, do what you think, but I'll just put the answer here. We can talk about this in class because, again, I don't like my videos getting longer than 20 minutes. But you'd be at 6, 8, and you can solve to figure out that x equals 6 and y equals -8. That's one way to figure that out. 11, you know, you'd figure out that a and b are both negative if you're going from 1 to 3. You know, you're starting, I don't know what one's going to be. Let's say 1's here, 3's down here. So to go down, you have to go down and to the left. Make sure when it says anything like justify or explain, you guys are really trying to make sure that your work makes sense. And essential question check-in. So how does a translating a figure using the formal definition compare to the previous method? Well, rather than sliding left or right or up and down, now you slide it parallel to a given vector that's equal to the length. So you give the vector's telling you what to do. So let's just summarize real quick. A couple ways to describe a translation would be, let's go back up to the essential question real quick, the EQ. It's a slide that moves the figure units horizontally, units vertically. It could be described as moving all the points the same distance in the same direction, right? Drawing an image by sliding a pre-image parallel to the given vector, a distance equal to the length, magnitude, and size. And it's using the paired coordinates to find the coordinates of the images of the vertices. So we talked about coordinate, using the coordinate rules. We talked about the component form. We talked about applying the rules. We talked about drawing. So before we go over what I want you guys to do for homework, the essential question, how do you draw the figure? How do you draw the image of a figure under a translation? You can use tracing paper, but we aren't going to talk about that. But you can see that it works. And if you have tracing paper, go for it. And on the coordinate plane, you can draw the image by using coordinate notation and then calculate the coordinates of the images of those vertices. Now, you see how there's a lot of vocab in geometry. If you don't know what these words mean, you're probably like swimming, right? So make sure you're learning what each of these things mean. I think this lesson went pretty smoothly. I really like transformations. I think they make sense. So let's talk about what you're ready for practice. Transformed again. So I'm going to leave this for you guys in the assignment in the Google Classroom, but this is what the practice looks like. You have lots of opportunities to go over all the things that we did. In the comments down below, I would love to hear what your favorite part of the lesson was and what your favorite transformer is. Mine's probably, I tend to go for like the typical hero of story sometimes, especially in a movie like that. So I'm going to say Optimus Prime. Bumblebee's pretty smooth though. I'm not a big Transformers fan, to be honest. Although I was at work downtown in Milwaukee when they were recording, was that Transformers 3, and they were using the art museum, so that was pretty cool. So I got to see just the hustle and bustle of all that. So yeah, I have everything that I have. So this is Mr. Hanson at Mr. Hanson 414. If you haven't subscribed yet, please do. And let me know what I can do to make these videos better for you guys. And I'll see you next time. I'll see you next time, guys. See you later.